In this lesson, we are looking at applications of systems of equations. Yes, word problems. We're going to first of all, let's just look at some familiar words, because part of word problems is translating words to mathematical symbols. So sum, we know is to add. Difference, we want to subtract. Twice is 2 times, and of course is equal. So on a previous lesson, way back, we did some word problems, and I asked you to do certain things. I'm going to ask you to do the same thing here. We want to define the variables, and this time we have S, variables. We want to write the equations, and we want to solve and make sure we answer the problem. These problems, we're going to get a system of equations. It's actually probably easier than just using one variable, believe it or not. Let's read number 1. The sum of 2 numbers is 26. The larger number is 5 more than twice the smaller number. What are the numbers? Well, we're going to use 2 variables. How about I'm going to pick x to be my smaller number, and I'm going to let y be my larger number. You could choose any variables you want. Let's go back and read the first sentence. The sum of 2 numbers is 26. Well, my 2 numbers are x and y. Sum means I need to add them together. So x plus y is 26. The sum of 2 numbers is 26. That's one equation, one sentence. Now I need another equation. Next sentence. The larger number is, so I have y, because that's my larger number, is 5 more than, remember I'm going to add 5, twice the smaller number. Twice means 2 times the smaller plus 5. So I've defined my variables. I have 2 equations. Now I need to solve. I have choices. I can solve them by the graphing method, the substitution method, or the elimination method. I'm never going to choose the graphing method. And this looks like it's pretty much set up for the substitution method since y is already solved for. So that's the method I'm going to use. So I am going to substitute this in to the other equation. So I have x plus, and instead of y, I have 2x plus 5 equals to 26. So collecting like terms, I have 3x plus 5 equals 26. Subtract 5, and I get x is 7. So I've solved. But have I answered the problem? No, because it asks what are the numbers. So I need x and y. Well, if x is 7, how am I going to go back and get y? You go back to one of the equations. So we can either go back here or here. I think I'm going to go back to here. Y equals 2x plus 5. So that's 14 plus 5. That's 19. So our 2 numbers are 7 and 19. You can kind of check. Their sum is 26. Add 7 and 19, I get 26. Larger numbers, 5 more than twice the smaller number. Those all check. The difference of 2 numbers is 12. Twice the larger number plus the smaller number is 18. What are the numbers? So I'm going to use the same setup. I'm going to let x be my small one and y be my larger one. Now when I say the difference, that means I have to subtract. And when you first learn to subtract, didn't you always take the larger one minus the smaller one? That's what I'm going to do. The larger one minus the smaller one is 12. So the difference is 12. Twice the larger number plus the smaller number. Okay, hold on. Twice the larger number. My larger number is y, so twice the larger number plus, I know what that means, plus the smaller number, that's x, is 18. What are the numbers? Again, I could use the substitution method, but this one looks really set up for the elimination method because if I just add those together, my x's are going to be eliminated. So that's what I'm going to do. I'm going to get 3y equals 30. So y is 10. Not done, because I have to find both the larger and the smaller. So I'm going to come back and say, all right, y minus x is 12. What's y? That's 10. Subtract 10, divide by -1. So my two numbers are, oops, I didn't divide by, right? If I divide, I get -2. So my two numbers are -2 and 10. We've done money problems before. In fact, these are the same notes I used before. So just to remind you, to have money, you have to multiply how many you have times the value to get to the total money. So if Jan has $5.90 in dimes and quarters, she has a total of 32 coins. How many dimes and how many quarters does Jan have? Well, we need two variables. How about D for dimes and Q for quarters? Jan has $5.90 in dimes and quarters. If you just put D plus Q is $5.90, that's wrong, because I have to know how much money she has. So you have to multiply the value, how many of the item, times the value. So D is worth 10 cents. Q is worth 25 cents. So this is how much money Jan has. And so I'm using cents, so I'm taking out that decimal. Now she has a total of 32 coins. This is where you can say D plus Q is 32. That's the number of coins. Be careful here. I can either use the substitution method or the elimination method. I think I'm going to use the elimination method, and I think I'm going to do where, let's see, I'm going to multiply this one times -10, so I can have -10D and a positive 10D. So I'm going to copy the first one just like it is, and then I'm going to multiply everything by -10, add them together. That's 0. That's what I want. And I hope this divides evenly, because I cannot have a part of a quarter. Let's see, 15 goes into 27 one time. It needs to be 18. So I have 18 quarters. How many dimes do I have? I think I'm going to use this equation. Looks easier. So D plus 18 is 32. So subtract 18 and I get 14. Now remember, coins, you can't have a negative and you can't have fractions. So the money ones are a little bit harder. Let's do another one. Now we're talking stamps, same thing. So Elaine spent $5.96 on 12-cent stamps and 26-cent stamps. She bought a total of 31 stamps. Very similar to dimes and quarters. So I'm going to let X be my 12-cent stamps and Y be my 26-cent stamps. And just like on number 3, I'm going to multiply what they're worth times how many I have. What they're worth times how many I have equals to my money, and notice I'm using cents, so I'm taking out that decimal. Then my total is 31 stamps, and that's that equation. So again, you could use the substitution method. In fact, let's give that one a try. How about if I take this and I solve for x? So if I get x by itself, I would move the y to the other side. So I would substitute this into the other equation for x. So I'd have 12 times 31 minus y. Again, you could have used the elimination method. So I need to multiply 12 times 31. That's 372. So sometimes on these problems, the numbers get a little bit bigger than what you're used to. Collecting like terms, subtracting 372, and then I need to divide. If I take y and I have 224 divided by 14, that is equal to 16. So I have 16 26-cent stamps because that was y. Now, if I'm going to go back to the same equation and get x. All right, since x equals 31 minus y, using that one, 31 minus 16, I have 15 12-cent stamps. So make sure you understand how to set up those money problems. We get to practice one more of them. Actually, more than one. Let's see. Alex sold 32 tickets to the high school football games. We have adult tickets that cost $4 and student tickets that cost $1.50. He basically collected $103. How many adult tickets and how many student tickets did Alex sell? So I'm going to let A be my adult tickets, and I'm going to let S be my student tickets. Alright, I'm going to do the same thing I did on my other two problems. I'm going to remember the adult ones are $4 and the student ones are $1.50. Right, so I'm going to multiply what they're worth times how many I have, what they're worth times how many I have, equals the total money. And yes, I'm using that $1.50. Then how many tickets did he sell? 32. So A plus S is 32. Again, I could use the elimination method, but you know that substitution method wasn't too bad. All right, so I'm going to take this and I'm going to get A by itself, so that's 32 minus S. So I'm going to substitute this in to the other equation. So I have 4 times 32 minus S plus 1.5S, or 1.50, same thing. So I multiply. I collect like terms. All right, so subtract, take the sign of the larger. Subtract 128. And let's see, I need to subtract and take the sign of the larger. So really, the numbers kind of looked ugly, but now when I divide by negative 2.5, and I'm so glad both sides are negative, right, because you have to sell them at a positive amount. So I'm going to get S, but divide that, I'm going to get 10 student tickets. Right? Well, if I sold 32 tickets total and 10 of them were students, how many is adult? Can you do that in your head? That would be not 12. Apparently I can't do it in my head. 22 adult tickets. So the decimal's kind of icky, but ended up not too bad. Yolanda had 3 pens and 1 notebook for $1.70. 4 days later, she bought 2 pens and 2 notebooks for $2.36. What's the cost of each pen and each notebook? This is a little bit different because they tell you how many you bought, but they don't tell you the value. So I'm going to let P be the pens and N be the notebook. But I don't, in fact, this has got to be the value. I don't know the value of each. Let's see, I bought 3 pens, so 3 times P, 3 times the value of the pens, plus 1 times the value of the notebook equals $1.70. I think I'm going to take out those decimals. 4 days later, she brought 2 pens and 2 notebooks for 236 cents. Little different, because again, the P and the N is the value, like how much they're worth. So I think I'm going to practice my elimination method. I think I'll get rid of my N. So I'm going to multiply this one by not 2, but -2. So if I multiply by -2, I'm going to get -6p minus 2n equals -340. I think that's right. So dividing a negative by negative, I get positive. That's good news. So it's not 26 pens, is that the pens are worth 26 cents each. So I have to know how much the notebooks are worth. So again, pick an equation. I'm just going to go back here. So I have 3 times 26 plus n is 170. I think that's 92. The notebook is worth 92 cents. A little bit trickier. Probably need to pause and rewind and go over these problems one more time.